All right, so last thing we're doing today is generic four-step process. Like I said, we're going to be doing a bunch of these. All right, so this is what number? Number 5. We're in chapter 9. And this is a one sample hypothesis test for means. Oh, wait. Yeah. And this is number 5, chapter 9, and make sure you have your name on it somewhere. All right, so what do you expect to be part of the null hypothesis, part of the state, which is what this is? Part of state is definitely going to be what? Say it again.
The p-value sums.
So we have to find p-value within, so we're not going to start with it. So what was your homework for last night? Was all dealing with what? Null and alternative hypotheses. So it's definitely going to have null and alternative hypothesis. In general, we always, to some extent, define some things. What are some things we define? Parameters. What's our parameter we're going to be dealing with? Mu. And then what's the other thing we usually deal with, like, or define? Population. And sometimes we even do population and sample. In this one, we're concerned with what the population is based off of a sample, and our sample should be random. So really defining our sample isn't necessary because it's just a random piece of that population. So we define our population in context. Then you just said we define our parameter, which is mu, which is going to be the mean, something in context. And then we're going to have a null hypothesis, alternative hypothesis, because I am writing this one just to be for means, what's our first symbol of both of those going to be? Mu. Which one of those do I know the next symbol? I know the null hypothesis has to be equals. I've got 3 options for alternative. Less than, greater than, not equal to. And then we call this mu naught, but this is just some number, and which is the same number. And a lot of times I don't even call it mu naught yet. You'll usually just put a number there, not even think the fact that it's mu naught. When we get to p, we have to use p naught. And so I just go ahead and talk about it that way. And so our other thing is alpha, which we have not even talked about yet. So alpha, most people end up drawing like a fish. And so we're going to use 0.05 if one is not given. So I talked about this on Friday a little bit with, and how do we determine what is small enough or how far it needs to be? Our alpha is what we decide is like our cutoff for it needs to be less than this to reject it. So most of the time we use 0.05, which is 5%, as, or if it happens less than 5% of the time, that's when we're gonna reject the null hypothesis. But we talked about scenarios where it would make sense to do one higher or lower based on context. Alright, so plan. What's our first part of plan? Plan should get really easy. Method. You should know what the method is. There's only one word that changes from last chapter. What are we not doing anymore? Are we still doing one sample? I have to make a decision after one sample and decide if it is what? What went here last chapter? Interval. We're now not doing an interval, we're doing a test instead. And it's still for what? And then we check our conditions. What's our first condition? You know, when I'm like writing the fill in the blank from, hey, you should use this as your answer for all these, paying attention and writing it down probably would be a good idea, but that's just only going to be successful. So random, just like before, we do what here? And I want you to write this one the way you've been writing it, so if you want to grab your other one and make sure that, I've told you I vary it a little bit class to class. I want yours to stay consistent. So whichever way you wrote it before, write that the exact same way. We have to say that it's random assignment or random selection. I don't think we've seen a problem where it's actually random assignment yet in that condition. But if we don't see one soon, I might change one to make it so that we can see it. All right, what's our next condition? Normal. Well, how many ways do we have to check for normal if we're dealing with means? We got 3, so it could be, what's one of our, again, I want you copying this the same way we did it before, but what's one of our easy ways? And it's stated that what is normal? Stated population distribution is normal. On chapter 7 test, I kind of got some answers that, so a lot of people said stated it was normal, but you need to say stated that population distribution is normal. What's another easy option? So central limit theorem, you can spell. And central limit theorem is checking that what is what? Or I have to get to my third option, which is what? Histogram of values. Again, I want this written however you wrote it before. And I'm checking for 2 things. What are those 2 things?
No extreme skew or outline.
And I don't know why I write strong skew, extreme outliers and not use the same adjective, but I've gotten the habit of it, so I just keep it the same. And then regardless of which one of the three you choose, you have to end normal with significant normal approximation. And then what is our last condition? What do we check for independent? 10% condition. Which is capital N being greater than or equal to 10N, and then you write there or at least dot, dot, dot. Again, however you wrote it before, keep it consistent. And that one's in the population, if you did, I don't remember if you wrote that before. Again, just stay consistent with what you're looking at. All right, so do, we start with the symbols that the problem's going to give us. What are some things you think the problem's going to give us? Sample size. What else? We're dealing with means. We get a sample. So what do we obtain from that sample other than just sample size? X bar. We're also going to get a something or something. Depending on the problem. And then we're also going to get a claimed U. And then you're also going to have, if I should save myself more room here, it's either going to be one or two tail, which is where we started with today. When is it? When did we shade two tails? If the problem is what? Not equal to. If it's less than, it's one tail. If it's greater than, it's one tail. That part we deal with in a little bit. All right, so we find a test statistic which is basically finding Z. So we use X bar, our value minus our mean, divided by how do we find standard deviation for a sampling distribution of X bar? So like if I wrote out, you would write 1. So we're basically to the point where instead of going through multiple steps, writing this and then writing off the side what that equals, we just kind of go ahead and put that there. Or technically, it could be X bar minus U divided by what over sigma or square root of N, depending on which one it is. And then we have to draw and shade. Find the p-value of that test statistic. And then this is the part that I haven't talked about yet. We're then going to compare our p-value to our alpha. And I'm going to write this one kind of weird, but I want you to write it how I'm writing it. So we're gonna have p-value with a number below it, an alpha with a number below it, and it's either going to be our p-value is less than, or our p-value is not less than, and I write it that way on purpose. I know that that means greater than or equal to. So this should look kind of funny to you right now, and that is fine. But just write it the way that I have it, and then when we get to actually doing a problem, I'll be able to explain that better. What? Hang on, let me get through this first, because I don't know that there's enough. Alright, just write this with me. When we dealt with p-value being low or p-value being high at the very beginning of class today, p-value being low would mean we do what to the null hypothesis? Reject. Our other option is failed reject. So we have two options there, either reject or failed reject. And we make that on the decision of the p-value either being or not being less than alpha, and that's why I write that kind of funny on that last slide. So if we do reject the null hypothesis, does that mean we do or do not have evidence against the claim? So if we reject the null hypothesis, does that mean we have a bunch of evidence or we didn't have a bunch of evidence? When would we tell them that they're wrong? We have evidence or we don't? When we do. So this top line we reject if the p-value is less because we do have convincing evidence, or we fail to reject is not because we do not have convincing evidence. And then we're doing it in terms of the direction of the alternative hypothesis. So while y'all are writing, just because I said this earlier, it's not gonna be on the video, Monday, this coming next Monday, is wind testing. I don't think I have juniors in my classes. But wind testing, so all the juniors are doing wind testing. I think some seniors might be, I don't know. So they are holding everyone in your first period class until wind testing is over, which is like 1:30. So I'm telling you this ahead of time so you can make a decision for what you want to do next Monday. I'm not allowed to tell you that you cannot come next Monday. I'm not telling you that. So, but because I wouldn't see any of you guys anyways, third or fourth period, your notes would be posted online for that day regardless of whether you are here or not. So just keep that in mind for next Monday.